stormwater, water, and sanitary sewer. The strategy that was developed is basically we need to establish some sort of loop for the supply water, and most likely locating that during or in the green, the centralized green community green space. At which point we'll start our stub offs off of that with the 500-foot max line for all the other buildings. Then, and phasing of that, looked at possibly completing the loop in phase 2 with just stubbing off of the main line for some of the phase 1 development, depending on what that ends up looking like. And then also having a water tank up on top of that hill, assuming that we need that to keep the system pressurized for fire protection and other needs on site. The stormwater system, we have two systems. We're going to have one for the buildings and one for the drainage of the roads. And that's mainly to just separate the water caught from the rooftops and bringing that to one location in one tank and cleaning that and reusing that water. And then the water that's being filtered off of the tire bales and off the infrastructure of the roads to another tank, so that can be monitored to make sure that there's no contaminants that develop in that water. And then if there isn't, we can be able to reuse that water on site. And so that would essentially be along one side of the road, our major road system, for both of those systems and the major buildings. However, in the residential area, we would still have the drain for the roads, but we're looking at doing more of a surface drainage system for any stormwater or water from the rooftops there, and collecting a lot of that decentralized collection for the residential area. Anything else on water?
Other than, these are kind of some details of, from stormwater, we talked about rainwater barrels for the houses, right? Again, so it can provide water to irrigate if you have your own plot of land, a little area for vegetables, etc. Again, you can do some of that. And we also talked about the mini grain gardens within the different residential zone and within the green buffer zone. Again, to manage the stormwater, clean the stormwater as it goes down through. So,
and manage that surge of larger storms.
So very low intensive in terms of infrastructure in the residential side until you get to a main line, and then it comes out to the very end, and then the storm bells or the drain for the tire bales.
And bringing that all down to the southern part of the site where we're doing our food production and other types of water cleaning and all that.
Good. Next one back.
And then that's just a cleaned up version of that.
Sanitary.
So this is the sanitary lines running again to that main line near the water line down the center of the green space, and then down to the bottom, the south end, where we'll have our centralized sanitary cleaning systems and our storage tanks for that first surge, so that we can capture that.
And then on this as well, one of the things we talked about was gray water in a lot of detail.
Yeah.
Do we provide a centralized gray water system or a decentralized system in terms of, on the residential side, reusing as much of that water? So there, a little analysis still needs to go on there between that centralized versus decentralized system. So, and I just kind of threw that on there just to make sure we understand that we still need to do a little work there.
So yeah, so the centralized system
it'll be about money in the end.
Centralized system would be bringing everything down to the cleaning system at the southern end of the site, cleaning it, and then bringing that gray water back up into the site, pumping it back up to be reused in the buildings and the other structures. The decentralized system would be to have the grouping of houses, kind of have the houses separate the black water from the gray water, store, treat, and reuse that within the clusters of houses, so that can kind of be built as the development expands and as a cost, and then analyze the cost of those.
And it's about maintenance of that cleaning of the gray water Do you want that individualized within the home, or do you want that centralized as a group, right? So it's kind of that thought process with some options.
And then from the energy side, we've got the main grid. We'll be connecting to that grid. We're also going to be analyzing storing all the energy on site and the viability of that from both a supply of energy, but then also a cost of that storage system. But then the potential, or the probability of connecting to the grid, potential of having a meter there for the entire site, so that we could then, at that point, send the electrical lines out to all the buildings and have a shared grid or a shared utility on site. And then the buildings may all be sub-metered off of that, so that we'll know how much the buildings are using. We'll be able to then, if the building is producing more than it's using, we'll be able to use that on site, at a 1-to-1 cost ratio. And all the energy that's not used on site, if we do still have a surplus, could be then sold back to the utility, which typically you only get 10 cents on the dollar for selling it back to the utility. But that needs to be figured out with the utility company on how that works and what that cost structure is.
So one of the things we did do is we did some calculations on what it's going to take to make it net zero from an energy standpoint. From a very rough scale, the house is being 120% that you guys have already designed. Some of the buildings being a little bit negative in terms of can't produce enough electricity on the rooftop.
The more densely populated buildings.
Exactly, and then there's a few areas in which will again be over 100%. But we think we can do all that with PV and one 100 kW wind turbine, which is about 150 feet tall. Would be up on the hill, right? Is kind of what we're showing there.
Or maybe the potential of some smaller ones, but looking at how all that fits on the site. So that's.
You said 100.
One 100 kW.
From what we know right now, it works, but we may be able to, and we're checking with some vendors right now just to get a better understanding of production here. That was from just general numbers and not site-based numbers. So.
Are you guys talking about heating homes too, or just cooling?
This would be total energy used on the site. So that would include electricity, gas, any kind of input you have into your house. So we don't distinguish between electricity and gas so much, but we didn't talk about gas. We're assuming electric. I assume you guys were assuming all electric as well, right? With the geothermal system. So
but then
in this case, it's all
gas. You still may need some gas for cooking needs or some other needs.
Propane, gas.
And that energy is just converted to all one unit, and we just offset that with electricity, essentially.
The commercial side, probably the gas is very expensive to heat workspaces and high ceiling environment.
Well, it depends on the type of mechanical system we have. If we use a geothermal system, then that would do both heating and cooling, and that would be electric-based. So it does depend on the system, but we've used averages overall based on the building types of total energy. So,
So
pick your source.
just run through that list.
We should write them.
Okay. You want to read here? You read out right.
Okay, perfect. All right, so some of the things we came out with task. One of the things we still have on the site, we still have to define a 100-year floodplain, and we know KLG is going to do that with. Where's KLG.
But they said they'll be looking for marching orders.
Yes, okay, so they're going to help us define that 100-year floodplain with the water expert that was here, and I don't see him right here at this moment. We need to check the overall water flow in the site. There were some questions about, well, does the site really all drain to the south? We think it's going to drain all to the south, but we need to revise that, and that's on us, on BNIM. one of the things we have to clarify is the reuse within the buildings on the demand side. We need to calculate the size of these storage tanks to see how large, how big these need to be. We are going to do a analysis on gray water demand, basically, based on some of the other input we heard, like 12 people to a house, right, which is what they're using for their models. We're going to go back and recalculate those demands so we can size these tanks. We have to do the calculation on the centralized versus decentralized gray water system, and that's a cost benefit analysis.
So you're still going to do that analysis?
Yeah.
So what's your assumptions about that?
I think it's a good, we need to see the demand, especially when we're thinking about 12 people, what we're going to do with all that water. I went from like we didn't have enough water to like, wow,
That's so much water.
once we have all this water, what are we going to do with it? So, and then we are going to cost out the cost for a centralized system, which would have overflow capabilities beyond the building. So, my hunch is maybe centralized, but it was a tough call. It wasn't just clear. Let's put it that way.
And that'll be DPA and us working together.
There was lots of different options on the actual wastewater treatment system that we talked about. We need to do some cost analysis on the different systems, on the wastewater treatment systems. Again, we're talking about lower cost, but ecologically still sound systems. So there's a couple different systems there, so we're going to do a cost analysis on that.
And I think, I'd love to get that information from you about the packaged plants that you're familiar with to help us, to help us further analyze some of the cost feasibility of some of those.
Other tasks. Well, one of the tasks is we got to lay out the plan, right? Initial concept of the plan based on all this input, which we'll be working on over the next couple of weeks. We'll send that out for comments, right? And then we'll revise that. So that's just a task that needs to be done. The fire protection water line, there needs to be some sizing done there based on some additional information.
Let's be clear that because everybody participated in this process, when he's done, when BNIM is done with that initial site plan, that's going to go out to everybody that's here, and you'll have an opportunity to give your comments, and then there'll be another draft.
Right.
And then that's the one that I take to the tribe and the community after. Correct?
That's correct.
And I think the timeline.
Yes, timelines.
I'm just saying.
Yeah.
The initial, what me and Josh were talking about is the initial draft
Yes.
by end of next week.
Right. Right.
So by close of business on Friday, you'll have initial site plan for review. And so over the weekend or the following week after Memorial Day or whatever.
Make sure we kind of capture that.
Yeah. If there was something that was 100% missed, we want to make sure we get people's comments.
Okay. Moving
You
on.
said that a little more. I said, next week.
At least you know where to stand.
All right. Moving on to energy vendor production numbers. We need to get some. We've already been talking to vendors about wind and PV. We need to get final numbers from them in order to put it into our equations to finalize that. Storage system.
And also with that, Rob, in terms of the calcs that you guys did for the production of the solar, was that done by You said something from NRAIL?
Dylan, who works for us, works at NREL
Okay.
and is consulting on the project.
Okay, and then was that, would there be added benefit in verifying those production numbers with some local solar providers?
Of course.
Okay, so I think us working together with
Absolutely.
that,
We
that
should do that.
context.
Yeah, absolutely.
Sounds good.
There was the talk of the storage system. We're going to do some basic research on that, see what kind of general the costs are. I will tell you that first I thought, well, it's probably going to cost a lot of money, so we need it. But we'll check into it and see what it's going to look like. We need to talk to the utility contractor, Buck Creek Electric, about net metering and what kind of a deal they can support, maybe, or initial reactions to our plant, because that's a big deal, which will help us identify how we want to set up the metering. They really, to me, it's more about metering within the community. So, road foundations. One of the things we talked about was feasibility of bales for slab fill. Foundation design, and that was more about compaction test that needs to be done. And I think that was pretty much everything that we talked about, except we did talk about roads in general. We're talking about no curbs on our roads, all right? Again, we're using that as part of our stormwater strategy. We talked about actually a not reduce, but a slightly smaller section for the roads for the residential, 22 feet versus 24 feet, but still providing enough parking space for 4 cars at each house, right? So it's a double width driveway underneath the shelter, underneath your shelter, because there's talk about, well, there can be lots of cars, potentially. So, but to try to move them in off the street and into that parking area was one of our thoughts. We also talked about an access easement in the back, about trails, and the thought of creating those access easements so that you could have, instead of sidewalks out front, which is where we're collecting our stormwater, it would be really in the back as a communal idea. And then we talked a little bit about, well, okay, what if somebody wants a fence in their yard? Well, we create this easement so that you really couldn't do it. You could still have a fence, and you could fence in part of your yard, but maybe just not to the complete border, was the idea.
Or you have to put some kind of
Gate, yeah, there's some of these trails in my neighborhood, and people will have their fence, and they'll have a little gate in the back, and yeah, you can kind of go through the backside. I think that was everything we talked about. And
Walking track.
what?
Walking track.
The walking track, yes, we did. You're right, absolutely. We talked about the walking trail around the perimeter. That's also our burn break, essentially around the perimeter. We didn't draw a diagram of that, but that's still included within the project. Yeah. Anything else I missed, or we missed? Okay.
Let's see. The tire bale use and the foundations. Let's see. Who was the geotech? And are we able to task you guys with looking into that a little bit and just checking some feasibility? Just early feasibility?
What we suggest, we're not expert on the tire bells, like Penn State and the tire that's company, it will be better for the feasibility studies. What we are suggesting to do some research on the environmental side and the mechanical side of the tire bells that are used for road construction and foundation of the buildings.
Yeah.
And I think Pennsylvania State University Center for the Dirt and Railroads and I forgot the name. John and Mr. John and his company
So,
It's recognized as a lifetime issue,
yeah. So,
Because you wouldn't be able to get financing.
so what we talked about, and you guys can correct me wrong, we talked about under the houses, we have shallow foundations. No. We were talking about the flex space, the bigger warehouse space. And in a diagram, this is your foundation, this is your grade, that's your slab on grade, and then the walls come up from here, of just filling this space here, because one of the structural engineers said because of the type of material we have on site, we're going to have to over excavate these pad sites anyway. So, because of the clay. So the idea was really just using that as fill, I call it as fill, right, underneath the slabs for compaction. So not in these zones here. You know, that's a little different equation.
Okay.
You know what I mean?
Good.
Does that make sense?
Yeah.
So, but,
That makes a lot, I mean, that's consistent with what we were already doing, minus the bales anyway. I mean, we just, I think the conclusion is,
Yeah, that makes sense.
yeah.
because we've used all kinds of material as that fill before to get rid of material, encapsulated. So that's, to me, that's not a foreign concept. But there's quite a bit of area when you think about the bigger buildings that could apply to, but not the house.
And that's still the frost protection shell foundation kind of concept, slab on grade.
This,
That's a structural, that's a different.
this is a bigger building.
Okay, so those are for the, everything above 1,200 square foot type of thing?
Yeah.
Yeah, the houses are what is where you more or less.
Yeah.
That would be for non-residential structures.
Yeah, exactly. So the empowerment center, maybe, the warehouses, bigger bay spacings, higher loads.
And the reason to not do it in residential structure was because,
Well, in my mind, the research hasn't been completed yet on whether or not there is an off-gassing concern. We read the report that Colorado School of Mines put out, and it made recommendations for completely encapsulating them in concrete, but because of indoor air quality concerns. And so I think you need a test case, you need to monitor and create a research project that would monitor
Maybe we
air
could do
quality
one.
over time.
There's existing subdivisions that have been built with it.
So then you could take those as part of the research project and do some. But if it's not in the building code, and you're trying to apply for a 30-year mortgage, there could be an issue. It's considered an alternative material method, and that might get in the way of a mortgage. And you don't know.
so it was dropped.
I don't foresee that. I don't foresee that because the EPA has recognized it as this lifetime restraint. I understand that it might not be, but maybe that argument needs to be made.
And I'm not saying one way or another that it's the right or the wrong thing to do. I'm just saying in terms of issues that we might have to address, those would be some of them. And in terms of the frost protection shell foundation, there's not enough material needed for it that it makes a lot of sense.
I think that's, we can talk about the other issues, but I think that's a basic issue is that they're just not big enough. And you're not going deep enough. We're talking about going for foundations at least 6 feet down for these bigger buildings. So,
It makes sense in that.
there's going to be some major excavation going on there.
So
So,
commercial warehouses, the industrial buildings.
And plus, what we can do too is, just like, besides of what research is out there, let's do one of the research projects. Let's collect that data, because this is only a 34-acre development. I mean, the idea is a lot of everything that we're trying to do here with the housing and the roads, everything. It's about the 5,000 units, all that kind of investment. So, but is it clear? Was it clear? How is that going to move forward? Who's going to do that research, and what is that project? We didn't get that far.
We did discuss it. discuss components of it that.
Well, they nodded their heads other way. There was this, and then there was.
So-
we had a discussion, Penn State and the University of Colorado and South Coast Alliance would certainly coordinate. We've got enough construction going on, we could include, one of the projects on that.
Yeah, I think ultimately we're gonna have to satisfy the structural engineer, whoever it is on the building, that if the test for compaction, density, and all that is good enough, they can look at it and say, yeah, that makes sense. You know, I mean, ultimately, that's what we're getting at, because we don't have a building certification.
Just to get into mechanical part, for the road construction, we have local companies that can cultivate develop meter pads. Once we fill the road and create the base there on top of tire bales, and we have capabilities we have some companies in Rapid City that can provide that quick stiffness results about the roadway design.
So if I repeat you correctly, as we're building the roads, we would test the action of the roads,
Yes.
to see if it meets the requirement.
Yeah, I mean, we can compare it.
Because it's really the same process.
Okay, I get it.
That's it?
Okay.
Yes.
I think, I was just looking at my notes, and I think there was one other question we were wrestling with that we didn't really get answered, and that was about how some of the costs for annualized maintenance would get apportioned back to property owners, to homeowners, to rental. Is there going to be an association? We need to go back to the finance group, I don't know, but I just think there's a way to make sure that we're going to capture how those costs get cared for over time.
So maybe that's a lead into the next group.
Yeah, we can.
Who's gonna pay